Greetings and hello everyone. Today we're going to be learning about angles and congruence. So let's start off with defining a bunch of different things that deal with angles. So a ray is the part of a line consisting of a point on the line called an endpoint of the ray together with all the collinear points. So we have A, we have B, and we have C. So this would be our ray. We can call this ray AB, or we could call this ray AC. Our next one we're going to take a look at is two collinear rays with a common endpoint are opposite rays. Opposite rays form a straight angle which has measure of 180 degrees. So we have A, B, C again. The common endpoint, we're going to have A and D over here. So here's two rays that create a straight angle. Our next idea that we're going to look at is an angle is a pair of rays that have a common endpoint. So we have our ray AD, and then we have a ray ABC. So this would be our angle right here. And we can call this angle A because that comes from the vertex. We can also call this angle DAB. We can also call this angle CAD. Notice that your vertex is the center part, and we're going to define vertex next. So the ray are called sides of the angle. The common endpoint is the vertex. So again, drawing the angle that we've had. So we have D, A, B, and C. So this would be side AB and side AD. And this is our vertex. Still piggybacking on this, points D, A, B, and C lie on the angle. So A, D, B, and C all lie on the angle. Now I'm going to come up with some more points. So points G, F, and H lie in the interior of the angle. So we haven't seen these points yet, but what would these points look like? Well, we're still going to draw our same angle that we're using. So I have D, A, B, C. But now I'm going to talk about points G, F, and H. So point G, F, H. And those lie on the interior. So that's inside of our angle. So that's all that highlighted area right there. That's inside of our angle. All right. So if we have points that are inside the angle, some of you might guess where we're going. We're going to go to points that are outside of the angle. So what are points outside of the angle? So let's take a look at the next part. So point I, J, and K lie in the exterior of the angle. So they lie outside the angle. So we have D, A, B, C. So this is our angle again. And then we have I, J, K. I, J, K. So those are points outside. We also have some special angle pairs. So we have adjacent angles. Are two angles that lie in the same plane have a common vertex and a common side. No common interior points. So that would be like this. So this is angle 1 and angle 2. So my common side would be right here. Our next idea that we're going to look at is called a linear pair. A linear pair is a pair of adjacent angles that sum to 180 degrees. So you notice that this makes that collinear ray that we were talking about before, which has a measure of 180 degrees. So these are two adjacent angles that when we add them together, we get 180 degrees. And then our last one is vertical angles. Are the two non-adjacent angles formed by two intersecting lines vertical angles are congruent. So 6 and 8 are vertical angles. 5 and 7 are vertical angles. So they're not next to each other, they're kind of opposite each other. And so that's how we get our vertical angles. And as we said, vertical angles are congruent to each other. So let's take a look at some example problems. So let's take a look at example 1. So we want to identify these different things. So use the figure to identify the angles or pairs of angles that satisfy each of the conditions. So we want to name all the angles that have D as a vertex. So D is right here. So all angles that have D as a vertex, well, we're going to have angle E, D, F. So this means angle. It's kind of like a slanted L. We also have angle E, D, G. Then we have angle F, D, C. Angle G, D, C. Angle G, D, H. Angle C, D, H. And lastly, angle F, D, H. Next up, name the sides of angle 2. So angle 2 is right here. So our sides are going to be here and here. So our sides are going to be ray BA, BA. And then our next one is going to be ray BD or BG if we want to keep extending it out. Name a point in the interior of angle. So let's start at the start of it. F, D, E. So point inside of F, D, E. And point that's inside of here, there's only one point in there. That'd be point A. Name all the points on the exterior of F, D, E. So that'd be all these points back over here. So we would have C, H, and G. All right. Let's take a look at example 2. So in the figure, ray BA and ray BC are opposite rays, and BD bisects angle ABE. As we learned last time from bisecting, that means that this angle and this angle are going to be equal to each other. If measure of angle ABD, so that's this angle right here, is 4x plus 14, and angle DBE is 8x minus 32. We want to find DBE. So we want to find what that measure is. What's the value? But as we said, that word bisects is going to make these two equal to each other. So angle ABD is going to be equal to angle DBE. So plug in what we know. So we have 4x plus 14 equals 8x minus 32. So we want to solve this out. So we don't have fractions. We don't have distribution. We can't collect like terms because we have nothing to collect on the left or on the right. We do want to isolate our variable. So I'm going to subtract 4x from both sides. I could subtract 8x from both sides, but it's going to give me a negative, and I want to try to keep it positive. So this gives me 14 equals 4x minus 32. I'm going to add 32 to both sides. So that gives me 46 equals 4x. Now I'm going to divide by 4. Divide by 4. When I do that, I'm going to get x equals 11 and a half. So now I found what x is, but now I got to plug this back in here. So 8 times 11 and a half minus 32. So it's going to give me 92 minus 32, which gives me 60 degrees. So the measure of angle DBE equals 60 degrees. And let's take a look at our last example, example 3. So this says an office lamp is made of 2 intersecting metal bars. So let's identify some information. So how many pairs of adjacent angles do you see in the figure? And let's list 2 pairs. So we have one with another one, so that's 1 pair, 1 with another one, that's 2 pairs, 1 with another one, that's 3 pairs, and 1 with another one, that's 4 pairs, so 4 pairs. So let's list 1 pair. Well, DBC and CBE. So angle DBC and angle CBE. Identify two pairs of vertical angles in the figure. So we want the opposite and we want the opposite. So two pairs. So the first one would be DBC with EBA. So that'd be this angle right here. So I'll do it in yellow with this angle right here. So those would be my verticals. And then this angle and this angle. So we would have angle DBC, angle EBA, and angle DBA, angle CBE. So those would be our vertical angles. Next up, let's take a look at C. How many linear pairs do you see in the figure? List each pair. So we see a couple of different linear pairs. We're going to see 4 of them in total. Let's list them off, and then we can go back and look at them. So we have angle DBA and angle ABE. We also have angle ABE and angle EBC. We also have angle EBC and angle CBD. And then lastly, we have angle CBD and angle DBA. Let's find the measure of angle EBC. So EBC. Well, we know these are vertical angles, so if they're vertical angles, the measure of angle EBC will equal the measure of angle DBA, so 138 degrees. Now let's find the measure of angle ABE. Well, as we said right here, ABE and EBC form a linear pair. So we're going to have 138 plus angle ABE equals 180 degrees. So the measure of angle ABE will be 180 minus 138. So that's going to give us 42 degrees. So there's a lot here. Go ahead and review through what we covered and have a great day.